Hi guys, this is a project. We are lifeboat pioneers and our project is called Nano Autonomous Search Technology for Rescue and Recovery Missions. This project falls under the theme of disaster management in the Smart India Hackathon 2025. Our aim is to build a compact robot system that can support rescue operations in disaster management. Like in disasters like earthquakes or building collapse, many people get trapped under the debris. Finding survivors quickly is very difficult using traditional methods. Human rescuers face high risk and large equipment cannot reach small or dangerous places. These delays reduces survival chances. So there is an urgent need for autonomous and intelligent system. So these are the traditional methods. We can see human rescuers and the drones which are useful to search the victims which they are under the debris. So this can reduces the chance of survival. So our solution is a small nano robot supported by deployed nano drones. That robot crawls through narrow gaps using multiple sensors to detect the survivors' hazards in real time. It can send signals to rescue team immediately after detection. This system is modular, cost effective, and scalable, which means it can be adaptable from industries, campus, or even smart cities. Next. And this is the small prototype, and which is a small nano robot which can crawl an air hybrid, ground and air hybrid nano robot, which is used to detect the survivals which are under the debris. And next, the innovation and uniqueness of our project lies in its ground and air hybrid design. The main robot moves on the ground, which small drones can be deployed for extended reach in the open areas. It uses AI-driven sensors fusion with thermal, gas, motion, and visual sensors, ensuring accurate results with fewer false alarms. The design is modular, so it can easily scale from small rescue units to large disaster management system. Then technical approach.
This prototype of our project, Edge AI with Raspberry Pi cluster. Edge AI means fast processing, real-time decision making, and works even without internet. Why we use Raspberry Pi cluster? A Raspberry Pi cluster is a group of multiple Raspberry Pi connected together, working as a mini supercomputer. ROS, Robot Operating System. ROS is not an actual operating system like Windows or Linux. It is a middleware that is like software framework that helps robot communication, share data, and perform tasks smoothly. Why we use ROS? Robots have many parts like sensors, cameras, motors, drones, controllers. Each part needs to talk with each other. ROS makes this possible. Provides a publisher handling navigation, mapping, computer vision. Multi sensors, AR sensors. An AR sensor use infrared lights to detect objects, distance, or movements. It has mainly two parts: IR LED, photodiode. IR LED, it is transmitter, emits invisible IR light. Photodiode, it is receiver, detects reflected IR light from objects. Why we use IR sensor? IR sensor can help with abstract detection, navigation in dark spaces, human detection, drone support. Gas sensor. A gas sensor is a electronic device that detects the presence and concentration of gas in the air. It converts gas levels into electrical signals, which can be read by the controller Arduino, and Raspberry Pi. Why we use gas sensor? Detect hazardous gases. Thermal sensor. Thermal sensor detects heat emitted by the object, animals, or humans. Every object with temperature above absolute zero emits IR radiation, and the sensor converts this into temperature map or heat signals. Why we use thermal sensor? Human detection. Arduino can read data from the sensors and control devices like motor, light, and buzzer. It is very popular in the robots because it is easy to progress, reliable, and work in real time. Why we use Arduino? Arduino is used as a bridge between sensors and actuators. Reads sensor signals, process basic logic quickly, controls hardware, communicates with Raspberry. Next.
Nanorobot, which we discussed the technological approaches in before. So we are discussing, and these and sensors are compressed under the small nano robot, so which can be detected and detect the presence of the victims. It can also send alarms to the rescue teams, and it is crawl on the ground by using the light also.
Next, feasibility and viability. Our system is our system is feasible because it uses existing easily available technologies like sensors, AI chips, and small drones. And we have some challenges, and there are also strategies to overcome the challenges. The challenges include like limited drone flight time, communication problems in harsh environments, and occasional false alarms. And these are the some of the challenges. And to overcome these challenges, we have some strategies. We propose docking strategies for auto recharging, and to to communication issues for communication issues, we have reliable communication and AI driven sensor fusion for higher accuracy, and regulatory issues are handled by keeping drones lightweight and compliant with safety rules. And we have some impacts and benefits. The potential impact of our project is very significant. It will make rescue operations faster by quickly locating survivors in collapsed buildings or disaster zones. It increases the safety of first responders by reducing their exposure to risky environments. It also provides real time information about hazards and surroundings, helping in better decision making. And there are some benefits, and socially it saves lives and protects rescuers. Economically, it reduces cost of long rescue missions, and technologically it pushes forward the use of AI and robotics in disaster management. These are the some of the benefits. And this is the difference between the existing technologies and our device. And in case of manual search for victims, there is a lot of time mismanagement. The chances of victim survival decreases. In case of using machines, when the buildings has collapsed and the victims are stuck in the buildings, the machines are too late for finding the victims. They will fall under the problematic situation. For these reasons, we are not moving forward with these type of rescue missions. In case of using technologies like drone technology, they can only observe the top view of the incident areas and couldn't find the victims who are under the buildings. Now we coming to our device, it will move into the narrow area which above cases are not performing this type of operations on, and it will identify the victim's pinpoint location, and it will reduce the time for rescuing where we can say the victims.
These are the links which we are referred for our project. Thank you for the mentors, team members, and our institution. I welcome any queries, and if you find any mistakes, please do comment below. Thank you. Thank you for your attention.